Welcome back to Mr. Burton's class. Today we're going to go ahead and take care of the I do for lesson 2, relations of rational numbers. So I went ahead and chose a question that I thought would help you all the most. I do consider this the highest leverage task of this assignment. So if you can do this, then you'll know all about sets and subsets and how to classify the rational numbers. So first, let's go ahead and start off with some basic information that we absolutely need to know. The first thing that we need to know is we need to know the different sets and subsets of rational numbers. So the first set that we need to know is counting numbers, which I'll represent with a C. Counting numbers are numbers 1 through infinity. Yes, infinity. Infinity means it keeps going on and on and on, okay? Now we're talking about positive whole numbers, okay? Not fractional numbers at this point. Positive whole numbers. The next thing that we're doing is we need to put another circle around that C, and this circle is going to represent whole numbers, okay? So this is counting numbers. This is whole numbers. Now, what's the difference between counting numbers and whole numbers? Very simple. Counting numbers is 1 through infinity. Whole numbers is 0 through infinity. The only difference between counting numbers and whole numbers is the number 0. Now, let's move on to the next one. We have counting numbers. We have whole numbers. Now, the next one on our list is going to be integers. I'll represent that with an I. Now, integers are going to introduce negative infinity through positive infinity, okay? So please don't get this right. Please don't get this one confused with a negative. It's not negative, it's just through. So maybe I'll change that to say through. Okay, so this first one is 1 through infinity. That's counting numbers. Whole numbers are 0 through infinity. And integers are negative infinity through infinity. And please remember that these are all whole numbers, okay? We have not gotten to fractional numbers or rations at all yet, okay? We get to fractions and rational numbers with our next circle, which is, make that circle kind of big, but this one is rational numbers. You guessed it. With this one, we are introducing rations, partial numbers. So it is still a negative infinity through a positive infinity, but just plus fractions. And that's it. That's the difference between the sets of rational numbers. Now, please remember that counting numbers is fully inside of whole numbers. So if the number is a counting number, then it's a whole number. And guess what? It's also an integer. And guess what? It's also a rational number, okay? So we know this, but the one thing I want to ask you is, what if it's a rational number? Is it a counting number? Well, not necessarily. Remember, counting numbers are 1 through infinity, but they're whole numbers, so no fractional numbers. So what does that mean? In rational, we could have 1/2 up here as a perfectly fine rational number. But if we tried to bring this 1/2 down to the counting numbers, that would not work. And that is because 1/2 is not a whole number. All right, so let's take this information that we know about sets and subsets and let's apply this to a real life example. Now, the real life example that I have is here to the left. It says, I'm going to go ahead and read it. Venn diagrams are useful for organizing information about sets and subsets. So already I know we're probably going to be talking about a Venn diagram. Use the following information about a restaurant to make a Venn diagram. Okay, so first thing I want to go ahead and do is I want to go ahead and box in the statement. The statement says, use the following information about a restaurant to make a Venn diagram. Now, what do I know about Venn diagrams? Well, from my previous knowledge, I know that Venn diagrams are circles. So yes, I know that Venn diagrams are circles that overlap each other, creating a center area or a shared area. So I drew my first circle. I'm going to go ahead and draw my second circle. They don't have to be perfect, just two circles that overlap each other. So now that I have my Venn diagram built, now I'm going to go ahead and read the question. Okay, Tino is the manager of Sandwich Paradise, a restaurant with several other employees. Claire, underline, Leah, Elle, and Jim are all waiters at Sandwich Paradise. Claire wears glasses. Leah wears glasses and earrings. And Elle wears earrings. Jim wears neither glasses nor earrings. And then if we go back up to the top, it says, use the following information about a restaurant to make a Venn diagram. Okay, so the one thing I want you to understand is, yes, the circles need to be overlapping, but does it just need to be two circles? No, it can be more circles than two. So we have two circles here, but there's more information that we would want to include in this. So let's rewrite our Venn diagram in a different way. So let me erase these circles. All right, now that I've erased those circles, now let's go ahead and let's analyze the information to see what would be the best Venn diagram to represent all of the information that's presented to us. So the first thing that we know is that all of these people work at the restaurant. So let's make a circle that encompasses all of the people that we're talking about. And represent them. All right, so we have that circle. Now, we know that Tino is the manager of the restaurant. Do we need to represent Tino there? It says use the following information about a restaurant to make a Venn diagram. So yes, it doesn't say specifically these type of employees. We need to go ahead and include Tino. So let's go ahead and let's make a circle that says employees. How about that? So this circle, let's put employees. And so with this circle being employees, we know that all the rest of the circles will fit in this circle because the information is about all of the employees that work here at Sandwich Paradise. So in the employee circle, we're going to go ahead and put Tino because this is the one thing that he has in common with the other employees there. So I'm going to go ahead and put Tino. And now we can keep going. So the next circle in the Venn diagram that it says is that Claire, Leah, Elle, and Jim are all waiters at Sandwich Paradise. So Claire, Leah, Elle, and Jim would all be represented in a Venn diagram circle that represents, you guessed it, waiters. All right. After we have this waiters circle, Then we have Claire wears glasses, Leah wears glasses and earrings, Elle wears earrings, Jim wears neither glasses nor earrings. So what we need to do is we need to go ahead and in this waiters area right here, we know that we're going to have two more variables, glasses and earrings. But we also know that Jim doesn't wear either glasses or earrings. So Jim would fall under the employee circle. He will fall under the waiter circle. But once we start creating circles for glasses and earrings, that's where Jim doesn't fit in. So therefore, we're going to go ahead and put Jim in this waiter's circle. All right, we have Tino done. We have Jim done. We have Leah, Elle, and Claire. I didn't see Claire there. Is that everybody? Let's see, Tino, 1, 2, 3, 4, 5. Okay, so yes, that's everybody. So now we have Tino represented as an employee. He's the manager. So he's not a waiter, but he is an employee there. So we represent him in the employee circle. Then we have Jim, which he doesn't wear earrings or glasses, but he is a waiter and he is an employee. So he fits in the waiter's circle and he also fits in the employee circle. Then we have Leah, Elle, and Claire. Leah, Elle, and Claire either wear glasses, earrings, or both. So what we're going to do is we're going to create two circles that overlap each other inside of the waiter's circle. I'll show you why in just a second. So first thing we do is let's create that first circle inside. Uh-oh. And now let's go ahead and create the second circle as well. All right, so now that we have our two circles and we have the overlapping area in the center, we can go ahead and assign one circle to glasses and we can assign the other circle to earrings and assign the middle area as shared area or both. So I'm going to put a G on this circle to represent glasses. I'm going to put an E on this circle to represent earrings. And I'm going to put a B right here to represent both right in the middle. Now, let's go back to the problem and let's read so we can figure out for Leah, Elle, and Claire where their information goes. So it says Claire wears glasses. It doesn't say anything about earrings for Claire, just glasses. So I'm going to go ahead and put Claire in the glasses circle because she is an employee, she is a waiter, and she wears glasses. So let's put Claire right over here. All right, now that we've taken care of Claire, let's give her a check mark and let's go to the next person. It says Leah wears glasses and earrings. So Leah would be in the both area, and that's simply because she wears both glasses and earrings, as well as she's a waiter, as well as she's an employee. So Leah falls into all of the categories. And finally, let's go ahead and talk about Elle. So Elle, it says, wears earrings. So she doesn't wear both, she doesn't wear glasses, she only wears earrings. So she's going to go in the earrings circle because the earring circle, she's also a waiter and she's also an employee. So she fits under the circle of employee, waiter, and earrings, just not glasses. Let's give Elle a check mark. Let's make sure that all of our information is represented in the problem. Tino is the manager of Sandwich Paradise. We have Tino here as an employee. Check. Claire, Leah, Elle, and Jim, they're all waiters at Sandwich Paradise. They're represented under the waiter circle. And since Jim doesn't have glasses or earrings, that's where he is. So now we have Claire wears glasses only. So Claire is in the glasses circle. Leah wears glasses and earrings. Therefore, Leah's in both. And Elle wears just earrings. So she's right over there in the earring circle. And like we said, Jim wears neither glasses nor earrings. So that works out. Everybody is accounted for. Everybody's checked off. And we're all done. This is your final answer. Just remember, with sets and subsets, if you have a subset like glasses inside of a set like waiters or employees, then that means that everybody that is in that subset is also in the set. So everybody that in this set that wears glasses is also a waiter, and they're also employees of Sandwich Paradise. Hopefully you enjoyed that lesson. If you did, go ahead and leave a like and go ahead and subscribe if you want to. I'll be back with the next lesson very soon. Peace.